All right, everybody. This is the last lesson of the unit, lesson number 10, page 353. Up until this point, all the polynomial functions we've basically been dealing with had a leading coefficient of +1 or -1. In other words, they looked something like this, or negative x cubed plus 2x squared plus 3x plus 1 plus -1. Obviously, not all polynomials have a leading coefficient of + or -1, so now we're going to deal with ones that do not. All right, here's our polynomial function. It passes through this point. So there's our x value, there's our y value. You can see it has zeros at -1, 0, and 3. So if you write it in factored form, x plus 1, x minus 3. This c here is the leading coefficient. So let me write it in clear form here. This is a bad PDF conversion, sorry about that. We're trying to find c. So I know my x and y values that they pass through. I just sub them in. We're going to do down here because it gives us a bit more room. So our y value, -24. Our x goes in for all our x's. This is essentially the y value. Okay, so that's where the -24 comes in. C, put in my x, 2, 2 plus 1, 2 minus 3. C, 2, 2 plus 1 is 3, 2 minus 3 is -1. 2 times 3 is 6 times -1, so I get -24 is equal to -6c. Solve for c, I just divide out the -6, and I get c is equal to 4. The equation of this graph is t of x is equal to 4, and then you just write in all the factors, x plus 1, x minus 3. That's it. And you will know when to solve for c because I will tell you when to solve for c. I will say find the leading coefficient. All right, next one. The graph represents a polynomial function, lowest possible degree. It'll always be that. If it's lowest possible degree, you know that this 0 right here has to have a multiplicity of 3. And this one has to have a multiplicity of 1 because it passes right through. The x-intercepts are integers, i.e. whole numbers. Determine the equation of the polynomial in factored form. So we write it in factored form. Put in c for our leading coefficient. So this -2, that is x plus 2 as a factor with a multiplicity of 3. And the 2 here is just x minus 2. I'll put it in, but you don't have to. Multiplicity of 1. So now we need an xy point that it travels through. They don't tell us anything. But if you look at the graph, that y-intercept, and these go up by 5, 10, 15, no, they go up by 4 is 4, 8, 12, 16, 20. So that's 4, this is -8. So -8. This point here is x is 0 and y is -8. So those go into here. So it's -8. C. 0 is nice because 0 plus 2 is just 2. 0 minus 2 is -2. 2 cubed is 8. 8 -2 is -16. Divide out the -16. And you get, reduce it down. 1/2 is equal to c. So the polynomial is 1/2 x plus 2 all cubed x minus 2. That's it. All right. So what if they don't give you a graph like this one? Determine the equation in factored form of a fourth degree polynomial which passes through the point blah blah, so that's my xy point. Tangent, remember a tangent is when the graph bounces at a point, which means the multiplicity equals 2. So it has tangents at the point 2, 0 and negative 3, 0. These are your x-intercepts because it's x, y, and if y is 0, it's your x-intercept. So essentially what it's saying is point negative 3 and the point 2, graph goes through them. And it goes through the point 1 and negative 12. 1, negative 12. Let's guess there. It's 1, 12, negative 12. All right. So, right. So we write it out. P of x is equal to c plus 3 to the power of 2 x minus 2 to the power of 2. Again, that will give us our fourth degree polynomial, which makes sense. You add the multiplicities together, put in our xy values. Negative 12 is equal to c 1 plus 3 squared, 1 minus 2 squared, 1 plus 3 is 4, 1 minus 2 is negative 1, 4 squared is 16, negative 1 squared is positive 1, divide by the 16, so, and then reduce negative 12, or 12 over 16, 4 goes into both of those, so that'll reduce to 3 over 4 is equal to c. So the polynomial is that should be positive 16, and then that will be negative. There we go. That makes way more sense. Negative 3/4, or for you people that don't like fractions, negative 0.75. X plus 3 squared, x minus 2 squared. Doesn't ask you to, but if you were to draw it, negative leading coefficient makes sense because it would bounce there, go through that point, and bounce like that. And there you go. And this will be the point in the class where I stop, give you some practice questions. So at this point, if you want, you can stop the video and do numbers 1 to 4. Okay, once you've done that, hopefully that made sense. We're on to the last bit here. The only difference with these is we have fractions as our x-intercepts. And there's a way to deal with them. So, fourth degree polynomial passes through the point 1 and 2. There's our xy values. They give us the zeros. Okay, so always write polynomial in factored form. So if you have a 0 of 0, that just means you have x by itself, because it could be x minus 0, but nobody would write that. The negative 1 will be x plus 1. The 2 will be x minus 2. And this is the new thing. 3 halves now. That's the way you want to write it. But if you look here, integral coefficients, which means whole numbers. Okay? Which means you have to convert this to a whole number. So we're going to do it right now, because you can do it later and I'll show you. Got some more work to do later. This will give you the same 0 as 2x minus 3. That gives you a 0 of 3 halves as well. And if you convert it right away, everything works out nicely. I will show you how you can do it without that. You can do it at the end, but it's more work, like I said. Set x that. Plug in your x and your y. So 2 is equal to c. 1, 1, 1 minus 2. 2 times 1 minus 2. 2, 1 minus 2 is negative 1. 2 times 1 is 2, minus 3, negative 1. Negative 1 is positive 1 times 2 times 1. So I get 2 is equal to 2c. Therefore, c is equal to 1. Pretty boring. But if it's 1, you don't have to write it in, but I will just for this one. X plus 1, x minus 2, 2x minus 3. There we go. Okay. What if you didn't change this one? So if you don't change that one and you plug in your x and y, you're going to end up with 2 is equal to cx. Whoops. I'll plug in 1. And plug 1 into there. 1 plus 1, 1 minus 2, 1 minus 3 halves. Right away, if you don't like it, because we have fractions, but I'm just going to show you that you actually get the same number. C times 1, 1 plus 1 is 2. 1 minus 2 is negative 1. Now, 1 minus 3 halves, do a common denominator. It's going to give you negative a half. You could do it with decimals, but you know my feelings on decimals. All right, so 2 is equal to 1 times 2 is 2. 2 times negative 1 is negative 2. Negative 2 times negative 1 half is 1. Look at that. So essentially I get c is equal to 2. You're like, okay, Bolden, that's not the same. But if you write it out, put that in. Remember, we're using this one here. X plus 1, x minus 2, x minus 3 halves. And then I take this 2 here, multiply it into here. You could put multiply into any one, but they want integral coefficients, which means whole numbers, so we have to get rid of this fraction. I then get x plus 1, x minus 2. 2 times x is 2x. 2 times negative 3 is negative 6 divided by 2. It's negative 3. That is the same as that. But you got to do a bit more work at the end, okay? And you deal with fractions or decimals. So this is my preferred way, but I don't really care how you do it as long as if they say integral coefficients, you give me everything as whole numbers, not a fraction. Whoops. Okay, last question. Polynomial equation has the following 3 roots. Let's get this. Negative 2 is a root with a multiplicity of 1. So if negative 2 is a root, that means it's x plus 2 multiplicity of 1. 1/3 is a root with a multiplicity of 2. So that means it's x minus a third multiplicity of 2. We'll fix that in a sec here. 1 is a root with a multiplicity of 3. So that means minus 1 multiplicity of 3. The graph has a y-intercept of this. If they say y-intercept, that means x is 0, which means we have coordinates 0 and 2/3. Okay. Determine the equation of polynomial function in fact form using integral. So soon, like I said in the one above, as soon as you see the integral thing, rewrite this at 3x minus 1 all squared. Again, you could use this and go through what we did. It's even slightly more complicated if you do it that way with a squared, but you can do it. This will make your life a little easier. All right. So we write out the polynomial. Put in our leading coefficient that we're trying to find, c, plus 2, 3x minus 1 squared, x minus 1 cubed. Plug in our x and our y values. So 2/3, don't be afraid of the fraction. It will all work out. C, if I put 0 in for these, 0 plus 2 is 2. 3 times 0 is 0 minus 1 squared. 0 minus 1, negative 1. 2/3 is equal to c. Negative 1 squared is positive 1 times negative 1 cubed, which is negative 1, times 2 gives me negative 2, like that. You can divide off the negative 2. Now, it looks ugly, but if you remember, when you're dividing fractions, you flip the denominator. So essentially, that's like negative 2 over 1. So it's like that. Those 2's will cancel, and you're left with negative 1/3. So the polynomial is negative 1/3 x plus 2 x minus 1. Oh, I'm running out of room. And then x minus 1 cubed. All right, and they didn't ask you to graph it, but we'll graph it anyway, just as for practice. Our zeros are negative 2, 1/3, 1. The degree of the polynomial, remember, add the multiplicities. 3 plus 2 plus 1 is 6. And our leading coefficient is negative. And it has a y-intercept of 2/3, which is, well, let's guess, right there. So that means we come up at negative 2, it's a multiplicity of 1, so it passes through, comes down. At this 1/3 is a multiplicity of 2, so it bounces. And then this is our point of inflection. That is our POI, because it has a multiplicity of 3. All right, that is it. I would like you to do questions 6 to 8 and number 13. Let me know if you have any questions. And that's it for this unit. I will post an assignment, our first quote-unquote test, but it's really just an assignment. The following, next Monday, I guess. This is going out this Monday, so this will then the following Monday. All right. Stay safe, everybody.